In this class, we're going to take a deeper look at domain and range. Sort of a brief introduction the other day when we talked about functions and the idea of a picture frame, what parts include it. We're going to go sort of more in depth with that, I think, today. So again, reminders, domain is your X values, range is your Y values. If you have a mapping diagram that are nice and easy to find, you can make a list, because the mapping diagram gives you the X's and the Y's. Oops, fancy one. X and Y values are used for that function. Again, these are both functions because each X only points at a separate Y. Anyway, like mapping diagrams, they're already in order for us. If we're not given a mapping diagram, we can use our ordered pairs. The only trick is we've got to put them in order. So we find the smallest X, and then the next smallest, and the next smallest, and so on. Take it to the highest. Range, we look at our Y's. And you see a 2. There's 2 of them. We only have to write it down once. There's also 2 3s, but again once, and the single 5. There does not have to be the same amount of numbers in each bracket. The nice thing about these is you can see the parts and pieces that are being used. Okay? They're specific. They're these nice whole numbers that you can look at. We're not always going to have that situation. Sometimes we're going to have to ask ourselves, is our relation or function made up of individual points, integers, things that have specific values, or are they made up of connected lines? Lines include the integers, but they also include all the small numbers in between them. The difference in how we see a picture is the difference in how we're going to have to approach our answer. So let's look at the first thing. This is a graph. This graph is made up of points. If it's made up of specific points, I can simply make a list for my domain and my range. So my domain, my x's, I'm going to find the smallest one first. The smallest one is going to be the furthest to the left. So the furthest to the left would be this one. It's got a value of -3. The next furthest to the left would be this one at -2. I've got one at -1. I've got one at 0. I've got one at 1, one at 2, and one at 3. So making a list of all those things. That's my domain. My range, I'm going to do it in a different color so it's easier to tell apart. My range, again, has to start at the smallest one. Our ranges are Y values. When we think of our smallest one, we think at the bottom of the graph. So the smallest Y value I have is down here at -2. And then -1. And I got one at 0. And I got one at 1. In fact, I got 2 at 1, but I only have to make a list once. I've got one at 2. I have nothing along the 3 line. Notice there's no dot along this line here at all, so I'm going to skip that. Nothing along there. My next Y value is actually at 4. Okay, now that wasn't hard. It was time consuming a little bit. We only had 2, 4, 6, 7 points. But it wasn't hard, right? We worked from left to right for our X's and bottom up for our Y's. And I can tell you by looking at this domain range, our entire graph would fit between -3 and 3 and -2 and 4, which it does. Okay, the problem is, what happens if I have a graph made up of lines? There's no way I can possibly list all the values that are included. For example, if I had a graph that started at 0 and went to 1, can you guys give me a list of all the numbers in between there? Well, no, you can't. It's not possible. There's an infinite number of fractions and decimals between 0 and 1. Every time you think you listed them all, you can add another decimal place or add another 0 to the bottom of your fraction or something like that. So we can't list them all. So when we come across situations involving lines, we're going to use something called set notation. And set notation refers to the set of the numbers included in an interval. And how we're going to do that is, first of all, we're going to say X belongs to R. In other words, X is a real number. For those who don't know what real numbers are, it's anything you can possibly think of. Every fraction, every decimal, every weird number like pi, everything you can think of is a real number. They exist. But what we're going to have to do is we're going to have to say the words, this little bar here, specifically. Which ones? And then we're going to have to decide on an interval. You know, talk about interval notation for a second. I'm hoping we know what that means. This means x is less than or equal to, because it has this little bar underneath, to 10. As opposed to, move it for a second, this one. That would mean x is greater than, actually let's make it even more fun, x is greater than 5. No equal sign, so not equal to. It's got to be greater than. So we're talking about our set notation. This thing up here, we're going to try and give ourselves boundaries. We're going to try and say it's got to be greater than 2, but less than 10. Or maybe it's got to be greater than 6, but less than or equal to 27. We're going to try and give ourselves some boundaries. And it might sound kind of confusing the first couple of times, so we're going to give these a try. We're going to do a bunch of them today. So look at the first graph. I'm hoping you would agree this is a line, not a bunch of dots. I suppose it is a bunch of dots, but it's an infinite number of dots, right? There's the dots here and here and here and here. There's all the dots in between those, right? And in between those, and in between those, and in between those. So this is a graph made up of lines. It includes every single real number. So I'm going to say that my x's, the x's I want to include all the real numbers. Specifically, I got to tell somebody, where's my picture frame? How far to the left does this graph go? It goes that far to the left. What is that value? Well, that's negative 4. So I'm going to say x has to be greater than or equal to negative 4. There's nothing below negative 4, nothing to the left of negative 4. When I read a graph, I read from left to right. How far to the right does this graph go? It goes all the way up to there. What's that value? That's positive 4 in terms of the x's. So I'm also going to say that x has to be less than or equal to positive 4. So this piece right here says x is between negative 4 and positive 4, including negative 4 and positive 4. There's dots on those values. Okay. If it helps, think of this as your left boundary, and think of this as your right boundary. Okay, let's try our range. Still made up of lines, but we're talking about the y values now. So y is all real numbers. Picture frame. How far down? What's the lowest y value we ever get to? And that one is right here. How low is that? Negative 1. How high does it ever get to? It gets all the way up to here, and that's 1, 2, 3, 4. So we're going to try and say that y has to be between negative 1 and positive 4. This is your down, and this is your up. Okay, and there's our domain and range. We've basically, if you look at the picture, we've created a picture frame. We've said here's where that graph exists. Let's try the next one. Our domain. Is this made up of lines or dots? I look at it, I see lines. So I'm going to start off by saying it includes all the real numbers, every decimal, every fraction, every whole number, and everything in between. How far to the left does this graph go? That's almost a trick question. I hope you notice in this question I have an arrow on the end here, as opposed to the last one which had dots on the end. Arrows signify that this graph is going to keep going. Where is it going to keep going? The same as it's been doing so far. So this graph's going to keep doing this. So how far to the left does it get? We don't know. It keeps on going. How far to the right does it get? Again, it's got an arrow. It's going to keep on going. So we don't know how far to the right it goes. In fact, it keeps going and going infinitely. So our domain includes everything. There is no left boundary. There's no right boundary. You cannot put a picture frame around this thing, because I've got arrows signifying they're going to go on and on forever and ever and ever. I might make you think in the range is going to be the same thing. Not necessarily true. Yes, it's still made up of lines. Which ones? How low does this graph go? Well, our arrows say it's going to keep going and going and going, getting lower and lower and lower and lower. So it has no low boundary. But it does have an upper boundary. So normally I'd have a number and then less than or equal to y, but because I have no low boundary, I'm going to get rid of that half. I'm just going to have the high boundary. How high does this get to? Gets up to right here. There's my top of my picture frame. What number is that? 3. That's my range. It includes every number as long as it's less than or equal to 3. Somewhere in this graph there's a y value of 2. Maybe these two spots, or a y value of 1, those two spots, y values of 0, and so on and so on. I can include any y value I want as long as it's less than 3. I'm going to try some more. I said these are a little tricky. You get the hang of it, you get lots of practice with it, you'll get better, and we're going to do them every day for quite some time, so you get better at it. Okay, domain. All real numbers. As soon as you see lines, you can write that part down. Which ones? Well, from the left, it looks like stops there. There's my left side. My right side, I see an arrow on the end, which means I can't worry about the rights. The right side's got an arrow. It's going to keep on going. The range. All real numbers. How low does it go? Again, it's got that arrow pointing down. I don't know how low it goes, but I do know how high it goes. It stops right there at 3. Okay, so we had boundaries on 2 of our sides, but not the other 2 because of the arrows. Let's try the next one. I see lines, so I can start off with my all real numbers. How far to the left? I've got an arrow on the left. How far on the right? Oh, got an arrow on the right. Guess I don't have any boundaries, so just all real numbers. How about our range? How low does it go? I've got a downward arrow. How high does it go? I got an upward arrow. It goes on and on forever and ever. So this is a kind of function like a basic old line, mx plus b, that would go on and on forever and ever in both directions. Just to point that out, a line does go on and on forever and ever. That's why I always put arrows on them, right? Okay, let's try E. E was kind of a trick one. Okay, let's take a look here. What do we notice? I see lines. How far to the left? I got a left arrow. Right there. How far to the right? I got a right arrow. I guess. Goes on and on forever and ever. Range. How far down does it go? Oh, I see a bottom. It's right there. There's no arrow pointing down. So it's got a bottom. It's the lowest. How high? I got an up arrow. So it goes forever and ever and ever. No high boundary. Okay, letter F. Now, letter F isn't actually a function. It's a relation. But the things you do with functions, you can often do with relations. Domain and range is one of those things. So our domain, how far to the left? I see -4. It stops right here. How far to the right? It stops right here at +4. A range. How far down? Oh, I got a low right there. It's -3. How far up? Right there. It's +3. Hey, I got myself a window frame. My picture exists inside there. A left and right, and an up and a down. Okay. Now, most of our functions aren't going to have boundaries on all ends. They're going to have boundaries on some of the ends, because we often have arrows on ours. A circle has no arrows, so it's got boundaries. All right, last idea. What if we take the picture away? Now, the other day I said we're going to keep coming back to grade 9, grade 10 material. We're going to have to recognize some things. There are some functions we absolutely positively have to recognize. Lines, linear ones, they're obvious. Mx plus b. They have no exponents, kind of the giveaways. Every line has a domain and range that's all real numbers. Okay, so x is all real numbers, y is all real numbers. The only ones that don't fit for that are your weird lines, horizontal and vertical, because they are horizontal and vertical. That is their domain and their range. Okay. The other thing we absolutely positively have to recognize is quadratics. Quadratics go left and right forever and ever and ever. They get wider and wider and wider and wider. But they have a domain, they have a range. They only ever reach a highest point or a lowest point. So if you can recognize that which way a parabola opens, you know what your window's going to look like. It opens down, It's going to reach a maximum, a highest. If it opens up, it's going to reach a minimum, a lowest, a vertex, in other words. So if we can figure those things out, we can figure out the domain range really quickly. We have to recognize our parabolas. Okay, so let's look at this example here. This is a parabola that opens up. And I know it opens up because my a value, this is a, is positive. Okay. I also know that the vertex is 1 and 5. So if I were to draw a quick picture of something opening up and a vertex of 1, 5, it would look like this. Well, what's the domain and range of that? That's pretty easy to figure out. And I just, by a real quick picture, figured out my domain and range. My domain, left and right, forever and ever and ever. I got arrows on the left and the right. My range, well, I reach the lowest of, what's that number right there? 5. And I go up from there forever and ever and ever. I got up arrows. I can do the same thing with the next one. I just got to figure out my direction of opening and my vertex. So my vertex is 4 and negative 5. And which way does this open? Oh, I see negative out front. That's down. So it's going to look like this. What's our domain? Oh, put those arrows on there, remind me. It goes left and right forever and ever. What's our range? Well, I have a low value. Oh, I don't, because it keeps going down and down and down and down. But I have a high value of negative 5. I never pass negative 5. My window only exists below that. Okay? But I have to be able to recognize a parabola to figure that out. And from a parabola, I also recognize direction of opening and the vertex. Okay, as I said, lines you should be able to just know right off the bat. Mx plus b, so if I came across something like 3x plus 1, I would know that goes like this. Left and right forever and ever, up and down forever and ever. All real numbers for domain and range. Okay, that's the end of this section here. It's the last thing from the handouts. We're going to get the books out next day. Try some of the questions. You're stuck on things, let me know. Come in, work through some things. These are still the basics. Function notation, is it a function, and domain range of functions.